Okay, so good afternoon, everyone. My name is Xiaofan Liang. I'm an assistant professor of urban and regional planning at Taubman College of Architecture and Urban Planning. I'm grateful to have the opportunity today to share with you my published paper, Lessons from a Human-in-the-Loop Machine Learning Approach for Identifying Vacant, Abandoned, and Deteriorated Property in Savannah, Georgia. So let me first introduce myself a little bit. So my research has two themes. So one focused on using network analysis to understand urban systems, such as how built environments condition spatial and social networks, and how that might create differential impacts on populations or places at the edge of the network. So, and additionally, I also examine how different layers of urban systems, such as transportation, social, digital, how do they coexist, interact, and compete with resource and power. So the second line of research theme, which is more aligned with today's talk, focused more on human-centered data and AI systems for urban services. So I approached this topic from a two-way street, so looking at both how data and technology, and now the new hype AI can better support planning practice in public services, and also the opposite direction, so how we as humans can proactively apply and challenge and govern such systems to better meet the urban needs as well as align with human values. So an example of urban service challenge that has been wrangled with is to address the vacant, abandoned, and deteriorated properties in shrinking cities. So this image shows you an example what an abandoned, vacant, and deteriorated properties look like. Right, so many cities, including Detroit, have still not recovered from the 2008 housing crisis and sustained population decline since the shift of economic focus away from manufacturing industry. So this creates a lot of loss of housing demand and also a lot of poverty conditions, which also deteriorate the housing conditions. So city of Savannah, for those who don't know where it is, it's a small and medium-sized city in southeast US. So this city is also a historical legacy city that experienced the same challenge. So the city has the largest port in the region and also has a long history dated back to be one of the oldest colonies in the United States. However, the city is struggling with a growing number of vacant, abandoned, and deteriorated properties, which I call VAD property to be simple, and a shortage of affordable housing at the same time. So why that happened? So the reason there's an affordable shortage of housing, it's also because all these housing that could have been affordable or could have been recirculated in real estate market now is sitting vacant in this case. So these properties are often characterized as having housing code violations such as broken window, dilapidated roof. They may have drug crimes associated with it. They also have a lot of tax delinquency, which means the property owner didn't pay the tax. They might also be vacant and have all kinds of public nuisance. So for each of these properties, the city is estimated to spend $1,300 to enforce code compliances every year. So things like the city has to mow the grasses for them. So these properties are often dead to the market, which means there's no buyers who would like to take over because they have tax delinquency that is higher than their property values. Therefore, they not only cause physical burdens on the city, but also lower property values in the neighborhood that they sit in because they're just a sore to the eye that no one wants to live next to an abandoned house. So what kickstarted our collaboration is this program called Georgia Smart Community Challenge. So that was this program I led when I was at Georgia Tech. So this is a funding program that dedicated money for university researchers and local governments to experiment the use of data and tech-driven solutions to improve public services. So when we first started with this project, the big question we have is where do we start? Where do we start with the problem? We're trying to figure out what is the context, what is the space that we're working at. So we're trying to triangulate across three dimensions. So one thing is what the city wants. So at that time, the city of Savannah is actually proactively searching for a technical solution because the city announced a very ambitious policy goal to acquire 1,000 properties to redevelop into affordable housing in 10 years. So their current approach rely on a small team of experts, actually n equals to 3 for the entire city, to acquire these appropriate properties based on tech sale opportunities that pop up. So it's very opportunistic, right? So they basically show up to the tech sale event and look at the property and decide, oh, this is a good opportunity to acquire. So there's no transparency, no standard method in that case. So to reach their policy goal, they need a standardized, scalable process and a transparent approach to scale up. So to find out where could be a sweet spot to start a project, we interview housing experts and also city officials and collected data and record of all the past effort they have done to try to find out what will be the middle of the triangle that we're trying to reach. So one thing we found out is that there's an effort that they started to try after they decided on the policy goal is the field survey, right? So basically, it's a windshield survey, officials driving to the neighborhood, marking down basically a checklist of does this property has a broken window, does this property has a dilapidated roof, etc. So that's the windshield survey. So you can see that the survey is quite limited in geographic coverage, and essentially the city lacks inventory data to make comprehensive plan, right? So they have no idea how many vacant property exist in their city. And there's also no prior example for any kind of machine learning training, which we found out after we get into the project. At first, we thought it would be a very straightforward machine learning project. And then we got into it, and then we realized there's no good ground truth, right? So the good ground truth should have been the historical acquisition data, which means the city identified that these are abandoned property that meet the acquisition standard, and they went on to acquire it. However, as you can tell, with a small team of people, the data set is really small. They have maybe around 100 property acquired in the past 10 years, which is average 10 per year, with like standard shifting every single year, right? So there's very small data set, also not very consistent. So how can we, as a researcher or the machine, learn if we don't have the learning material? So we decided to start from the first principle, so defining what are the characteristics of the vacant, abandoned, deteriorated property that the city is looking for, right? Because now they're looking for a very specific set of property given the policy goal. So we created this giant informatic through tons of interviews and conversation with the housing expert to consolidate our understanding of the social technical process of a property regeneration. Right, some of the text is a little small here, but you can see the scale of the information in it. So essentially I'm trying to see if I could get the mouse. Oh, yep. So these are the steps in decision making, right? So this is like housing and neighborhood service department. So they collect data and then they identify potential property target based on all these information, and they determine what is the good acquisition strategy. Then, after acquiring, different parties come in and get the property, and then the property goes to regeneration, which might be developed into affordable housing, right? So this whole process each decision involved data, and these data all goes to different variable, right? So for instance, variable public nuisance could come from data that's about code violation, and could come from other stuff as well. So this is basically a giant infographic that covers who's involved, what are their roads, how are decisions made in each step based on property conditions, and how are these conditions mapped to data variable. So the second thing we want to figure out is that what do we want to prioritize, right? So a little bit thinking backward from what is the final output we want to get. So for each of these decisions, there's a trade-off, right? So for each of these solutions that we could propose, there are trade-off, right? So I created this template to help with outlining or differentiating with different solution. So so the horizontal axis is on the left is like the solution is extremely expert intensive, could be very manual. On the right hand side, it will be automated, scalable. On the top side, it will be a solution that's very context aware. It could be more comprehensive or powerful, maybe able to capture the nuance of why a property would be identified as a good acquisition target. And then the one below would be more deterministic, rule-based. But the good side is that it's going to be transparent. Right, so each of these dimensions has something good in it, but we want to find something in the middle, right? So for instance, the field survey is extremely expert intensive and manual. You have to drive to every single property, but it's very context aware, right? Because you can document all these different details. And in contrast, if you only adopt a simple machine learning, let's say without any human in the loop, you just take a proxy variable to say, we don't have a good ground truth, but let's use, for instance, code violation as a proxy to say if you have a high number of code violation, you're likely to be vacant, and use that as a proxy for training. It's very automated, scalable, right? Because the data and variables are already there, but you will lose a lot of context and also won't be able to capture the nuance. what if there are property that has high co-violation, but it's not sufficient for acquisition. So an example of that will be a property owned by a slumlord, right? So a slumlord would be someone who don't maintain their property well, so they can let the window broken, they can let the roof, be a little broken, or they don't mow their grasses. However, there's still people living there. Then you can't really treat it as a good target for acquisition. So these are all just like we mapping our solution on these different scale to see the pros and cons of different of them, and making it really explicit to the city, right? So the city is actually initially exploring this linear scorecard system, which is very transparent, very rule-based, very scalable, right? So we want to make an argument to say we want to try something else, which is what we propose as a human-in-the-loop machine learning model to identify the vacant, abandoned, deteriorated property, right? So the advantage would be that it could be more context-aware and comprehensive and still maintain the scalability and while at the same time integrating expert knowledge in the middle. So after all these mental gymnastics, we go back to the chart and we essentially identify the second step to be the best place to intervene, right? So there's actually a lot of time we're spending on deciding where is the best place that machine learning should come in at all, if at all, right? So for instance, for acquisition strategy, we later realized that it's a very rule-based process, right? It's a legal process. Like you can acquire property based on these conditions. It's very deterministic. There's not much that machine learning can help there. However, the second step, identifying the target, there's a wider range of flexibility of what can come in there. So it's not completely rule-based. And there's a lot of complexity between the variable that determine whether a property is VAD or not. So what do I mean by human-in-the-loop machine learning approach to identify vacant, abandoned, deteriorated property? So it goes two ways. So for the human, which are the housing experts that we involve, so they provide contextual knowledge in every single step of the model development. So that includes both model selection, model variables, providing contextual knowledge of basically every single part of the project. Most importantly, we ask them to provide expert labeling to a small training set that we picked out for them to develop a robust training set, right? So as I mentioned before, there's no ground truth for the problem that we are addressing. And then on the opposite side, we want machine to also give back to the human, right? So what the machine does is that it finds the vacant, abandoned, deteriorated property that are most difficult to classify, which are near decision boundary, and then find the samples that are representative of different feature class, right? So let's say we had different clusters of housing property that has, some have more crime cases, some have more tax delinquency. We want to make sure that we have picked samples from each of these different representations to serve to the human experts. Essentially, we're trying to find a smarter way to pick the smallest set of sample possible, but representing the richest in the information and serve it to the human for labeling. And the second thing we have machine feedback to the human is that we have a mechanism, which I can go into more detail later, is to facilitate the consensus between the human experts. As you can imagine, 3 different experts looking at the same property with the same data variable, they might have different opinions. So how to resolve those opinions was the other contribution from the machine. So this is more of a technical demonstration of what the entire process looked like. So I won't go into too much detail here since the focus is on the sausage. But the step 4, 5, and 6, this is what a formal term called active learning technique will be applied to find out what would be a good set of sample for a human to label, how to design the labeling experience, and eventually how to resolve the inconsistency in the labeling. So what we have learned is that the human-in-the-loop machine learning approach is more accurate and can identify a greater diversity of vacant, abandoned, deteriorated properties than field surveys or simple ML models trained on a proxy variable. So on this side, you can see this is the results predicted by the human-in-the-loop model. This is what we consider an external validation, which is vacant property identified by the USPS delivery record. So this is not perfect either. This is not a perfect external validation. As you can see, it's mostly about structure because USPS doesn't deliver to vacant land. But you can see that at least in the geographic coverage, it most resemble the human-in-the-loop approaches results. And this is also a lot more, it covers a lot more area than the human field survey, and also more than a co-violation, right? So the co-violation had the same bias as the human approach because the co-compliance officer has to target very specific neighborhood and go in there to find their co-violation, right? So they actually suffer from the same bias in the source. And the second interesting thing we found out is that these different approaches actually differ in what features they emphasize in making decisions. So when machine is trying to pick out what property is a good target, we later realized that it relied on text delinquency a lot. So there will be a higher rate of property have text delinquency in the final candidate list. However, if you go to the human selected list, you will find a higher rate of property that have co-violation. So the reason is actually, it come back to us as like a aha moment later, because when humans go out to find these property, they rely on visual cues, right? So you actually had to see, there's some broken roof here, there's like litter here, the grass is not mowed. They're looking for co-violation when they're defining vacant, abandoned, disinvested property. They're not looking at text record when they're going out for field survey, right? So that explained why there's a difference between the human versus machine approach. And more generally, we also learned that incorporating humans in the loop introduces new complexity in addressing disagreement. In fact, we spent a lot more time than we imagined to try to resolve the different opinions between the human and also between the discrepancy between the human versus machine judgments. However, the other side of the coin is that our local housing experts or our local partner found that this exact process of resolving the difference is what's the most fruitful experience that come out of this project. Which is interesting because consider the fact that we never get the final product deployed by the city. Because city of Savannah is a small to medium-sized city, as you can imagine. After we get into the project, we realize their data infrastructure and governance framework are just not there yet, right? So for instance, we still have to manually requesting data from each of these city departments to get the data to put together. And their data collection process has a lot of bias that we are not sure how the data are collected from the first place. So after we had the model run and even have the results presented, I think the city still lacks the right person or the infrastructure to kind of take these data, visualize them, and integrate them into their daily practice. The other thing I learned is that the research and practice has very different priorities, life cycles, and timeline. Especially in many cases, there could be a conflict between a scientific value and practical value, right? So as a scientist, we want to develop new methods. We want to prove that we are superior than their traditional method. However, for scientists, for practitioner, what they want is something that they can take over and use immediately, right? So in this case, we actually spent 2 years struggling with the reviewers trying to prove our method is better while our practitioners are waiting at the sideline trying to get something out of this project. Right? So this process dragged really long, actually exhausted our funding and our energy to be able to respond to their practical need instead of trying to just get the project done and published. So if I lead a similar project again in the future, I think I would personally have more deliberation on when and how to join force with the local government. So I will look deeper into their data infrastructure and governance and ask whether they're ready to take on these projects, right? So even if we developed a very technical data-driven solution, are they ready to adopt it? Do they have the mindset? Are the people ready to take this back to their practice? And in fact, a more sophisticated model cannot save the bad data and a weak governance body to implement and sustain a solution. So for instance, one thing we learned is that the crime count data that we rely on to make prediction for the vacant property was not collected in a faithful way from the beginning by the police department, right? So this happens after we finish the whole project and we revisit every single variable. And the person official told us that the police just simply tag whatever crime incident that happened at the intersection of the road to the closest property. And we're like, oh, great, that breaks every premise that we have in the prediction, right? So the other thing is I will be looking for some more authentic human-in-the-loop approach. So while I started this project, human-in-the-loop is, in 2021, that's when I started. It was quite a fresh and new idea, and now it has gone a long way, right? So one of those development is to really criticize on the very extractive mode of human-in-the-loop, is simply just asking human to provide oversight or basically looking at a label and say, is this right or wrong, right? So I think more future project with the human-in-the-loop will definitely benefit from a co-creation model or thinking about different framing of what does it mean for human-in-the-loop to provide a different kind of research from the very beginning. And also really articulating on what will be the value added for communities and local governments, right? It doesn't mean, even if, researchers are aiming for a high-tech, high-complexity solution, but at the same time, maybe we can offer a low-tech and low-complexity solution, or even just curate a good learning experience from the research collaboration for the local community as an alternative takeaway. So lastly, what's next on my book? So I'm still interested in how can AI better support planning practice and urban policy. So in fact, I'm looking for a co-PI with NLP and LLM expertise or policy expertise for the Midas Pot grant on a topic around AI and zoning documents. How can AI interpret and extract structured information from diverse zoning documents? So zoning are legal ordinance that tell you where you can build at what land. So this has huge implication to support policy alignment in area such as affordable housing, coastal resilience, and renewable energy adoption. The other dimension I'm working at is just simply figuring out what are cities doing with AI today. So I'm leading a project that is analyzing all the public documents released by local government and trying to figure out what do they talk about regulation, what do they talk about governance, and what kind of application the city has already started to experiment and adopt in this case. And I'm also piloting a new course called Urban AI at Taubman College this semester as also an experimental space to figure out an intersection between the two spaces. All right, so lastly, thank you for all the human in the loop who enabled me to give this presentation, especially my co-author Cleo Andres, senior planner Brian Brainerd, and Tara Hicks at the City of Savannah. And thank you all for listening to me today.
Okay, I see one question. Nathan's going to bring a mic to you.
Thank you. This is certainly an interesting application. There's been a long history of efforts to apply machine learning, and they've led to deployed applications going back to the 1980s. So, but every time you come to a new one, there's new challenges. There always are. At least in this kind of setting. I mean, if you got a company like Google, then you could just upload your model to the web. That's much easier. But this is old school challenges. So I do want to encourage you to stop using this term human in the loop. Okay, it's not a new idea. We've had interactive learning systems since the 1980s. It means so many different things to so many people that it basically is almost has no information content. Now, active learning is a very well-defined approach that has also been around since the mid-1990s. And one of the things that surprised me in your talk is you said that it increases accuracy, and I don't know quite what that means because active learning was designed to improve the rate of learning, that is to decrease sample complexity. So you get the same accuracy with less data. And so if I were you, I would have reported learning curves that show how accuracy improves as a function of the size of the training set. And I think that would be a more informative analysis of what you're claiming it's doing. But I mean, active learning certainly can provide benefits. I would just be cautious about that. I also want to encourage you and everyone else to stop using this crazy phrase, machine learning model, which means nothing, okay? I mean, this is a fairly new term. Machine learning's been around since the 80s. We would talk about a learned model. It's not a machine learning model sounds like it's the model of machine learning, which you don't mean, right? It's not the machine learning that's doing the prediction, right? It's the learned model that's doing the prediction. So think about your terminology. I know you're just repeating what other people have said, but think about it, and everyone else should too. Thanks.
Thank you for the feedback.
Respond if you want.
I'll respond really quickly on the active learning side, right? So Our goal is not to try to prove the active learning. We adopt it in the sense that we use active learning to pick the small training set effectively for human labeling, right? So we're not able to scale that to say, a 10 data set, like 10 data point, 20 data point versus 100 data point, how that would change. So that wasn't our main goal. So for the accuracy aspect, that means is when we validated with external data sets, so the USPS data set, how much that overlaps with the external data set, but also internal accuracy, which means just by separating training set and test set. So both of them achieve higher accuracy.
Thanks for your talk. Just wondering what kind of data you were actually using.
So the variable that goes into predicting include co-violations. Actually, I can go back to this graphic. So the variable that goes into it is pretty much highly dependent on what information they need to make the final acquisition strategy, right? Because eventually they want to be able to acquire these property, and there's very fixed category, let's say like text sell, text full closure sell. So those are very explicit that you need text delinquency data, right? So the variable include like co-violations, text delinquency, housing price, property values, and there's something called special assessment tax, which is a special category, which means the city enforce the code compliance for you. So let's say they enforce you to mow your grass or clean your litter, you never did. The city did it for you. They made it into the special assessment tax. So there's a series of variable that go, and crime count, and crime, which is another important one. So I think these are the primary one that we used.
So the violation is like they haven't mowed their lawn, is that?
There is like a series of different kind of co-violation. It could be like abandoned car in front of the property, or like your water utility is not functioning, or your window is broken, your roof is falling off, like all these structural deficit.
The folks that you asked, they go out and they look at these locations.
Yes. So for people who conduct field survey, they have a checklist that they basically go and check. Is the window okay? Is the water utility okay? Is anyone living there? Is it vacant? Like making the check.
Yeah, thanks for this talk. I think what you were saying about the passing things over to be deployed in governance is really relatable to anybody who's worked in civic tech. And I was wondering, what was it like coordinating with experts on creating like a system to do the annotations? Did you have to set up like some kind of a Google sheet? Did you make some kind of interface for them? How did you coordinate that?
Yes, so that also takes more time than imagined for setting that up, right? So like introducing lots of new complexity whenever you have extra step of human in the loop, right? So we initially started with just a simple Excel spreadsheet with all the variables of the property there, and then you have a drop down to select, based on all these information you've seen, whether it's a yes or no, whether you would think it's a VAD property. And then we later massage the format a little bit because the experts say, we like to look at things like vertical rather than horizontal. And then they want to compare some of the information together. In fact, we have to, for some of the, so for instance, at the beginning, we have variable weighted. For instance, we have crime count weighted, right? Because if you have a crime that's like 5 years ago, it's less relevant if you have a crime recently. So we have a weighted variable at the beginning. So we presented a weighted value, let's say like 1.5 or something. And then the expert come in and be like, we don't understand what 1.5 mean here. So we had to actually unpack those variables back to their original form to say, this is the crime count, and in how many years, that's like how the in which year the crime happened, right? So we had to do a lot of these minor adjustments for expert come in to make sensible labeling. And then eventually we also asked them to provide rationale after their label. So let's say they classified this as VAD or not, and then they had to write a short paragraph rationale of what drives their decision.
Thank you. Yeah, no, I just ask, it's kind of reassuring to hear that it was an Excel sheet, because if I'm trying to figure this out, and the best I have is a student writing something custom, so I guess there isn't an easy solution. Interesting, thanks.
Any other questions? Okay, thank you so much. That was really interesting.
You know any good properties we can buy in Savannah?
What's it? Sorry, can you repeat?
Do you know any good properties for sale in Savannah?
Oh, actually, I got asked by the person who I lived with at Savannah and asked me for investment suggestion, and then I told the person that most of the property I recommended is in the low-income African